Welcome to this video on Ohm's Law Basics. Ohm's Law states that the current in a circuit is directly proportional to the voltage and inversely proportional to the resistance. Now that can be seen in Ohm's Law, which says, or written out in equation form, I is equal to V over R. So if you look at this mathematically, if V is in the numerator and it goes up, then that means I will go up. That's assuming R stays the same. If this number V goes down, then I will go down, assuming R stays the same. Now, we can prove that mathematically. So let's look at our circuit here where we got a simple voltage source, an ammeter to measure our current, I total, and a resistor. Let's apply 10 volts here, and let's say that we have a 1K ohm resistor. Now let's use Ohm's law to calculate this. So our step here would be writing out the equation. We'll say I total, just to make it match the letters in our circuit, is equal to V sub S divided by R. Now, substituting in those values for V sub S and R, we have 10 volts divided by 1K ohm resistor. Plugging that into the calculator, it will give us 10 milliamps. All right. Now, let's take the same circuit, but this time let's use Vs and R, and we'll change Vs from 10 volts to 20 volts. So this equation here now becomes 20 volts divided by 1K ohm. We haven't changed that resistance value. Substituting that into our calculator, we will get 20 milliamps. So you can see from this analysis that keeping resistance the same and increasing the voltage applied to the circuit then increases the current. Well, let's try it the other way, and let's say that instead of going from 10 volts to 20 volts, then we'll adjust the power supply down to 5 volts. We'll take the voltage down, leaving the resistance the same. The formula still is Ohm's law formula, and it remains the same. But now V source is 5 volts and still 1K ohm of resistance. So now this is, plugging into the calculator, is 5 milliamps. So this proves that increasing in a series circuit here with Ohm's law, if we increase the voltage, then the current increases, keeping the resistance the same. If we reduce the voltage that's applied, but keeping the resistance the same, then the current goes down. So there is a direct relationship between the current and the applied voltage. Okay, now we could ask the question is, how does varying the resistance in the circuit with a fixed voltage affect the current? Well, we can analyze it in the same manner as we did before, and what we'll find out is the current generated by fixed voltage decreases, the current decreases when the resistance increases, and increases when the resistance decreases. So they're inversely proportional. Now, using Ohm's law, we'll just write it again here, that the total current in a circuit is equal to the source voltage divided by the resistance. Now, let's go back to our original circuit where we had 10 volts and we had 1K ohm resistor. Okay, so now substituting in that, we're going to get the same thing as we did before, but let's just plug it in so we can see it. The source voltage is 10 volts and the resistance is 1K. ohms. And as before, that gave us 10 milliamps of current in the circuit. All right. This time, let's keep the voltage the same but change the resistance value. So here we'll go again V source, writing out the equation. Divided by R is going to give us a total current. This time we're going to leave the voltage the same at 10 volts, but we're going to increase the resistance. And let's say that we go to 2K ohms. Substituting that in, that will give us a current of 5 milliamps. So, by keeping the voltage the same and doubling, in this case, the resistance, then the current went down by 5 milliamps. Or, as you can see there, increasing the resistance reduces the current. Okay, well, let's try that again, but go the other way with the resistance. So here is the same formula again. We will keep the voltage the same. It remains at 10 volts. But now we will reduce the resistance to, say, 500 ohms. Plugging that into our calculator will give us a current of 20 milliamps. So as you can see, by reducing the resistance by half here, we have double the current. So the relationship there again is that the current generated by a fixed voltage decreases when the resistance increases and increases when the resistance decreases. So through this analysis, we have shown that if we have a circuit where the resistance remains constant and the voltage is changed, then the current in the circuit will respond proportionally. That is, notice here we went from 10 volts to 20 volts in the circuit and the current went up. We went from 10 volts to 5 volts and the current went down. Okay? All right, so they respond directly to each other. However, when we talk about resistance, then when we vary it, if we keep the voltage the same, that when we kept the voltage constant and we increased the resistance, then the current went down. And here, when we reduced the resistance, the current went up. So that's called inversely proportional. This concludes the video on Ohm's Law Basics.